Good evening, everyone. It's great to be here. I was really excited when I saw my time slot. I was really excited because I figured what I can do is tie together a lot of the concepts that were presented to you throughout the day, things like storage, ingest, processing, and delivery in my session, automated media workflows in the cloud. And then I realized, oh man, I'm the thing that's separating you guys from drinks afterwards. So I'm going to try and go as quickly as I can and get you to the drinks right just as soon as possible. Awesome. So my topic is automated media workflows. So the first question that probably comes to mind for many of you is why automate? I think Ivan probably did a lot better job of saying why to do that than I'm going to do right here, since I have a lot more to present on. But really, the simple answer is the world of media is getting more and more complex, right? Everything that you see, any events that you go to, you'll hear a lot about 4K video picking up in popularity. And what does 4K video really mean to us? Well, the current estimates are that, for a good quality 4K video, you'll probably need to be able to do about 20 to 30 megabit of streaming, and that's significant, right? I mean, today, typical high-quality videos, 2 megabit. Some people push it all the way up to 8, but nowhere near 20. And what does that come? What does that extra size really mean? It just means that there's more weight to everything that you're doing, bigger files, and so on. So size is important. The number of formats is growing rapidly. And the reason why the number of formats is growing is because there's more devices that we need to deliver to, more devices that we need to support. And that's all getting multiplied by the fact that there's more users that want to consume all this stuff. So there's a lot of reasons I think that we can all agree that automation can help. Being able to push content from a source mezzanine file all the way through to the end users without having to take manual intervention. So the way that I want to present this is really to give a scenario that I hope makes sense to a lot of you. Right? This is something that that we see with a lot of our customers. Basically, the scenario is at any given time, there's a company X, produces 10 broadcast quality shows. Each show consists of, let's say, 230-minute episodes per year. A high-res post-production copy of these shows are stored somewhere at some companies, at this company X's studio. I'm picking Tokyo, and I'll explain why I'm going to pick Tokyo a little later. But that's where we're saying that these files will be. And the content must be made available for distribution to consumers via web, mobile devices, media players. Again, the idea that multiple formats. So lastly, we want to say that the high-res content needs to be archived for future access for whatever reason. For like Ivan brought up, there may be needs to do massive retranscoding, and so you want to be able to get those assets back. And who knows what the future will bring for a show that you're producing. So this is the scenario that I want to walk through. And what we're going to be doing is presenting a framework to answer these questions, and then doing a demo. Hopefully everything works. But doing a demo showing you how you actually can do this and using the AWS services that you've seen already. So those requirements, that scenario, I would say I classify that as business requirements, right? These are the things that you know that you need to do to solve a problem. As an engineer, when I want to try and solve business type problems, I break it into technical requirements. So the first step for me is to say, what does this look like in terms of some sort of diagram? So for me, I see a workflow that consists of 3 steps. One, ingest, getting the files from Tokyo to somewhere that I'm going to do the processing. A processing phase, which is generating the different types of the different formats for delivery to the different devices. And then a delivery phase. How am I actually getting it from the post-processing stage to the end users, to the consumers? So I'm going to add a little bit more detail to this really simple diagram at first. And that's a framework to basically be able to go through these steps in AWS. So with AWS, you've heard a lot about the different storage services that we have. And S3 is a fantastic place to put the videos. Once you've ingested, you can do all the remaining steps can go to and from it. So we'll be using that. And we're using different flavors of S3. We'll be using standard storage and reduced redundancy. And then for the archiving perspective, we'll be leveraging Amazon Glacier. So that'll give us a place to keep the content as we move it through our pipeline, the middle 3 steps. Now the next question is, how are we pushing it through those different phases? And for that, in today's demo, we'll be using Amazon Simple Workflow Service, SWF. So we'll see how that all comes together. So just what we're going to do now is go through each of these different phases and go through what the details might look like on how we can solve them. So ingest. We have content in a data center or a studio in Tokyo, and we want to get it to US East. That's our region, one of the regions that we have here in the United States. And the reason why I picked Tokyo, like I mentioned, I'd get to that. The reason I picked Tokyo is it's far away. And so I wanted to give you an example of, well, if you're far away from one of our regions, or the region that you specifically want to do the processing in, there's great options on how to solve those problems. So far away means speed of light problems, right? It takes a long time to transfer files. So that's why I picked Tokyo. Now, one other quick side note, just so you know, we do have an AWS region in Tokyo. So if your studio was there, you probably would do the processing there. But we'll use it. We'll keep it this way. So the first question that you probably have is what's the fastest way to get data into S3? And so S3, Amazon S3, is basically an object storage system. Lets you the only way to access S3 is through web requests, right? So what you can do, though, with S3 is make those requests happen in parallel. And the simplest way to do them in parallel is to, well, there's many ways, but one of the simplest ways is to leverage our command line tools, our command line interface, the AWS command line interface. So that we have a new version of it that was released probably, I don't know, maybe about 2 months ago now. That if you've used past versions, you should definitely take a look at the new one, the Amazon Unified Command Line Interface. So what it'll do is take a source file, large file, it could be a gig, it could be anything up all the way up to 5 terabytes, and it'll break it up into a number of chunks. And it'll start to transfer those chunks in parallel over to S3. And what Amazon S3 will do is store each of those chunks as it's getting them. And then there's an operation at the end that can stitch them all together. So this happens completely transparent to you as the end user. You make a request to the command line, AWS S3 CP copy from your source file to S3, and it's going to do all that for you. And what that lets you do is get tremendous amounts of bandwidth. S3 regularly handles 1 million plus requests a second. So you're not going to really be touching that if you're making 10,000 requests a second. So you can upload 10,000 requests in parallel, stitch them all together at the end, and get incredible bandwidth. So that's the fastest way to get data in. It's not the fastest way to transfer files over a great distance, though. So there's 2 separate problems here to solve. And one way that you can solve that if you have a latency situation is to leverage one of the fast file transfer protocols that's out there. I think John Downey probably covered this a bit earlier on. So there's 2. I have 2 on the diagram. There's other here. There's 2 on the slide. I'm sorry. There's others. In today's demo, we're going to be leveraging Tsunami UDP. And the reason I picked that is because it's open source and it's something that's easy for me to package for you guys to consume it later on. But there are a significant number of benefits to using the commercial packages that are out there, something like Aspera. So what we're going to do is go from Tokyo to EC2 using Tsunami UDP, and then from EC2 to S3 by using multi-part uploads with the command line tools. And so it sounds like it's an interest. Oh, this is an old slide. Oh well. So I have actual numbers here. I can try and go off the top of my head. So the single thread test from Tokyo to S3 was 13 minutes and 25 seconds, I believe. So this is for an 885 meg files, which probably doesn't sound that bad anyway, right? Single thread, you can move about a gig in 13 minutes, halfway around the world, which not great, but not terrible. So multiple threads directly to S3. So if you ran that same command line tool that we're going to be running from US East to, from Tokyo to upload to US East, what you would see is a 92% decrease in the time that it takes, if I remember right. And so that came out to about a minute and a half, something along those lines. So by leveraging the multi-thread, you can make a significant improvement. But you can get even better. And the way to do that is, like I said, with the fast file transfer. So with fast file transfer, the Tsunami part, the part to go from Tokyo to EC2 instance in US East was 15 seconds. And then from EC2 to S3 was another 22 seconds. So 13 minutes roughly to a minute to 30 or so seconds, which is pretty significant improvements. This is on an 885 meg file. Many of you are dealing with much larger files. But that's roughly the order of magnitude of improvement. Fortunately, I think there's going to be a couple of other slides out of date as we go here, but I'll do my best to wing it. So on the processing side, what are some of the things that we may have to do to solve those requirements? Well, one is transcoding. That's the obvious thing, right? We're going to go from a high-res mezzanine type file to something that's usable, consumable on devices. This is another interesting part here. I put it under processing, but it's basically a way of we're going to have to select a thumbnail, right? So the end goal is to be able to deliver this somehow. So we're going to store something in a CMS, and so we're going to do a thumbnail selection as part of our processing phase. Metadata generation is another thing that you may need to do in order to store in the CMS, describe the video, and so on. And lastly, we're going to archive the video. So what does the transcoding look like? I'm not going to go into much depth here, just really quick, since I know you've heard this already. We're going to go from S3 through Amazon Elastic Transcoder to Amazon Reduced Redundancy Storage, again, back in S3. And it's really simple to do. We'll see it more in the demo. So I'm just going to say this is the choice that we've made for transcoding. In this case, you may use any number of other options. Certainly not limited to this, but in the demo, that's what I'm going to leverage. So this is the really interesting part. How many of you have heard of Amazon Mechanical Turk before? Pretty good number. OK, that's great. That's fantastic, actually. How many of you are using it or have tried it? Really great. OK, that's great. So what Mechanical Turk is, for those of you who don't know what it is or haven't used it, it's really a way of human process automation. So we looked at other examples of processing that computers are great at. So doing the transcoding, right? I mean, if I had to transcode a video by hand, I can't even, first of all, think about how that would be possible. But I probably could do a frame in a month, But there's some things that computers are much better at than humans. But if I look at the thumbnail selection, that's not something that a computer really can do. Or maybe there's some algorithms that are getting better and better, or whatever. But for the most part, a human can intuitively know what's the wrong thumbnail extremely easy, and then can probably pick between what the right thumbnail is pretty quickly as well. So we're going to use Amazon Mechanical Turk, and what we're going to do is submit an API request to Mechanical Turk to do a thumbnail selection. And the thumbnails are going to get generated by the transcode process, and the Mechanical Turk worker will select what he or she feels is the most appropriate thumbnail. And then the idea here, so Amazon DynamoDB could be an output of that. It could be your content management system. In this example, we're just going to bring up the video, since whatever the content management system is kind of out of the scope of what I want to do. So lastly, in the processing stage, is the archival to Glacier. So again, you've heard all the reasons why that's a great choice. I'm not going to go into it right now, but that's what we're going to do last step. So as we keep moving through our pipeline here, we have ingest, processing, and then discovery and delivery. So if we dive into that, We imagine that we have some sort of content management system that's running on EC2, probably in the same region that we chose to do the processing. And then the phase that is important for my discussion is how to actually deliver the bits. So the content management system will allow you to find the video that you're interested in or the piece of content that you're interested in, and then you'll click on a link. And when you do that, the video will get streamed to you using Amazon CloudFront. Bless you. So how do we do that? The last phase here is how do you automate this? And let's see, click. There we go. So we're going to leverage Amazon Simple Workflow Service today. And so what is Simple Workflow Service? It's basically a distributed. It's a service that maintains distributed application state for you, and in addition to that, allows you to track the workflow executions and gives you visibility into what's going on. So what does all that really kind of translate to? When you can imagine starting the workflow, you can submit a command to start processing a piece of content. What Simple Workflow do will record that, and it'll basically guide that through the rest of the process. Simple Workflow is not going to do the work for you. So to do the actual work, the actual transcoding and so on, you're going to be using the Amazon services. But to basically start, to schedule or to actually make the API calls to use the Amazon services that we've talked about, you'll have to write what we call deciders. Write worker tasks, activity tasks. And in addition to that, you'll have to create what we call deciders, things that can say, okay, we've completed, what's the history so far of a workflow execution? And based on that history, what should be the next step in the execution? So the decider is going to say, if you, again, just started the workflow, we haven't done anything yet. So let's schedule the first piece, which is ingest. And then a worker will pick up that, pick up the fact that it needs to do ingest. It'll go through it, and it'll say it's complete. And then the decider will say, OK, ingest is complete. Let's start the processing phase. So that's really what Simple Workflow is. It's a system to maintain the state of the application. And in addition to that, like I say, it gives you some, the visibility into it. So we're going to see in the demo, we're just going to look at the AWS console to watch the progression of a piece of content through our workflow. So when this is the primary slide that I had made other changes to, but the steps here that we're going to actually be doing today is we're going to start the workflow. We're going to transfer the a file to Amazon EC2 using Tsunami UDP, and then upload it to S3. When I first made this slide, I had those as two separate steps in the workflow. But realistically, they need to be the same step. And one of the reasons is you can't have them happen on a different node, right? So the whole idea with Simple Workflow is that you can have this distributed. You can have workers on a number of different nodes, and it can scale up. And so the transfer to an EC2 instance will result in the file being stored in that instance. So that's the node that needs to do the upload. So that's why it really needs to be the same step. From a transcode perspective, just for time's sake, I'm just transcoding to one output format, and that'll be an MP4. Then we'll do the thumbnail selection is actually going to be the next step. And lastly is the archive of the high-res video. So as a solutions architect, there are a number of questions that I have to ask before taking it any further at all. We have a plan now, right? We have a plan for how to answer these business requirements. Haven't written any code, haven't done anything else. We have a plan. So the next step for me is, I have to ask these two questions. Is it scalable, and is it fault tolerant, this plan? So the transfers, both the transfer to EC2 and then the upload to S3, there's basically an unlimited amount of bandwidth for you on the EC2 side. So this definitely can be scalable. Is it fault tolerant? Absolutely. If a node fails, this becomes part of one of the reasons why you're going to be using Simple Workflow. If a process fails, it'll just restart it on a different node, do what it needs to do to be able to get the file to EC2. Transcode step, like Usman pointed out many times in his presentation earlier, one of the reasons to use Elastic Transcoder is because you don't have to think about the transcoding process at all if you're using it. You basically make a call that says do this, and then in the end you'll get an output and it'll be done for you. And you don't have to think about scaling that. You don't have to think about developing your own queues or anything like that. The archival to Glacier. I'm sure a number of you have dealt with tapes in the past and all this other kind of stuff. And you'll see in this demo, all the archival is a copy from one folder to another folder. And then we have a policy set up to automatically archive it. So it's super simple. Mechanical Turk. By leveraging it, what you really basically get out of the business of worrying about is, is if Susie calls in sick, well, my video can't get a thumbnail or a caption or whatever it may be, because there's lots of people on the ready being able to that'll accept that piece of work for you. Delivery CloudFront, lots of edge locations. If there's any kind of problems, we'll automatically shift traffic over to a place that makes sense. So definitely meets the scalability and fault tolerance test. And then lastly is the automation elements. So I'm confident that a number of you are using some sort of orchestration tools or workflow engines. So the concepts here probably aren't anything new, but what I've seen for many of the customers that I've talked to is they're typically running this orchestration piece on a single server, and in a single data center. And with simple workflow, that's not the case at all, right? You're getting a distributed system that's across multiple data centers within a region, yes, but across multiple data centers and potentially multiple servers within one of those data centers. So you're getting an extremely fault-tolerant system, extremely reliable system to handle the automation pieces. So with that, it is demo time. All right. So just bear with me 1 minute. I need to get a few things set up here. Oops. So first thing I'm going to do is connect to my server in Japan. Assuming this actually does connect, that would be a good start. Let's see. Am I online? I know this page was loaded earlier. It does not look like it's refreshing. All right, let's try disconnecting and reconnecting. Sorry about this. Always the danger of a live demo. Whatever can go wrong will go wrong, right? So I'm sure this won't be the first problem that we have to overcome in the next 10 minutes. Any thoughts? Yeah, tried that one. Yeah. I could go with a reboot, but I know how long my laptop takes to do that, so probably would be done out of time long before it comes back up. Oh, that's a good sign. Let's see, get connected. Okay, I think we at least have internet connectivity now. You can put it back up. All right, so now we'll wait for the next problem to come up. So as I was saying, we're going to connect to our EC2 instance in Japan. Yes, we're connected. Which is, by the way, a cool thing in its own right? I mean, the fact that I can be standing here and controlling a machine halfway around the globe is pretty neat. So there's the file, Big Buck Bunny. I'm sure many of you have seen that before. It's not a new one. So I'm just going to basically launch a Tsunami UDP server. And this is obviously things that you'll have set up beforehand. But for part of the demo, I just wanted to go through all the steps that we would have to do. So we'll have our Tsunami UDP server on an EC2 instance in Tokyo. And then we're going to connect to an EC2 instance in Virginia. And we'll use that to start the workflow. Anytime Java's involved, I get nervous as well. So we'll see. All right, we're connected there. Oops. So I just want to make sure that the processes that I set up are running. All right, so let's run them. So what I'm doing here is running the decider process. So this is going to actually be making the decisions, and then we'll be running the task worker. And lastly, we're going to submit a job, and then we're going to watch it go through the whole pipeline, hopefully, anyway. So that's probably not a great sign either. So that should have shown something else. So we'll go into the simple workflow console and see what's going on. So no active executions. Select the domain, media workflow. One active execution, that's good. Okay, so it actually is going. That's great. So let's go back here and take a few steps back now that I see that it's actually running. So what I have here is the simple workflow console. We see that we've submitted a job for execution. If I drill into that job, I can see what the events that have taken place already. Like I mentioned earlier, you have visibility into running workflows and what the actual activities are that have gone on. So events are things like scheduled started the workflow execution, scheduled the decider picked it up and completed it. The activities are actually what kind of at a higher level view what's transpired. So we could see that the ingest is complete. It started at 17:42:41 and ended at 50. So it took about 9 seconds to transfer the file from Tokyo to US East. And then we started the transcode job. So what is the transcode? What is Elastic Transcoder? We're using Elastic Transcoder. So let's take a quick look at what Elastic Transcoder looks like. Here we have a pipeline defined, and the pipeline basically says what the input for the video or for the piece of content that we're acting on is, and that's going to be a bucket in S3 called Ally Demo, and then we look at what the outputs for that is. So we see we have for the transcoded files, the output is going to be another bucket, allydemo.out.vid. So this is where the output videos will be dropped. And then another bucket for the thumbnails, allydemo.out.thumb. And if you notice here, both the storage classes reduce redundancy. So this is where we're making that transition from standard storage to reduced redundancy storage. So that's the pipeline, is the framework for what's actually about to happen. If we look at the jobs, so this is going to be probably is already done. So we're not going to see anything right now. If I can always go back and look for enter new search parameters for completed jobs. And this is probably it. So we'll see in a minute. But let's take a quick look at S3. So Ally demo. We have a file that was just delivered there. So this is the file that was uploaded as part of the ingest. It's a smaller file than I mentioned earlier. The earlier one was 885 megs. I just wanted to use a smaller one to be a little bit quicker for the demo. And it looks like I have time to make up now that we had the connectivity issues. So it worked out well. So if we come back to simple workflow, we see that there's no active executions any longer. So that either means that things went really well and completed really fast, or we had some problems. Let's take a look. It looks like it went really well and completed really fast, which is great. The process thumbnail failed. OK. Oh, and then it completed there again. Great. So the rest of the process, we saw what the transcode looked like, and what the process thumbnail actually did was create a mechanical Turk request, as we said. So mturk.com. Just want to show this really quick and show you a sample hip. So this is what a worker would see. There's 273,000 hits available right now. So that's pieces of work for people to complete. So you can see there's a lot of stuff going on. And that was the transfer and things like that. So what did the person who actually picked up that piece of work see? They basically saw something that looked like this. I would have brought it up. Like I said, it just actually finished too quickly, which is a good thing, right? So they select the most interesting image for this video. Whatever descriptor that you want for the job, you can put there. You pick the image and click a submit button at the bottom. And that's how we got it. We got that. So going back to the management console, if we look at the output there, we'll see that they picked image 2. So what did that one look like? Just pull it up really quickly here. So that's image 2. That's what whoever was processing this decided to go with. And lastly, just to show two things. So we'll show the actual transcoded output. So nothing too surprising here. It's good old Big Bug Bunny. This is coming through CloudFront, as you can see. You can certainly have a custom domain name. Oh, nice. We have sound. So enough of that. And the last step in the process, which is to archive the video. So if we go back to S3, and we look at Ally demo, we had two video files in there when we first went through here. Now we only see one. And so literally to archive, all I had to do was copy it to this folder to archive. Whatever makes sense for you. And if we look at the bucket policies here, we have something called a lifecycle policy, which basically is a rule that says anything that starts with the prefix to archive should end up in Glacier within 1 day of dropping it there. So that's it. No worrying about tapes, nothing else like that. So that was the whole thing. That was the whole workflow from start to finish. I hope that kind of brings everything together a little bit in what you've seen throughout the day. And that's it. I think I did have one final slide, if we can bring that back up really quick. I know we're probably a little bit past time here, but just a couple of little reminders for you. You can get, if you're interested in getting started with this, there's walkthroughs on uploading videos to S3, running Elastic Transcode jobs, creating streaming distributions with CloudFront. And if you're interested in this code that you just saw run to actually do the media workflow, the full workflow, if you come to reInvent, I will have it perfected by then. It seemed to work pretty good today, but hopefully we'll have it even smoother there. and we'll make the code available to you. So that's it. If you have any questions, feel free to reach out to me. And you can see my email there, jman@amazon.com.